Hello, physical science students. This is the last section of notes for chapter 19. It's going to tell us about the types of chemical reactions. So there are four general types that we could classify different chemical reactions. The first one is a composition reaction, right? I want to think about this as being combining two things. So for example, we go back to our classic A plus B. They're going to be formed into one complex compound at the end. So composition reaction also can be referred to as a synthesis, because you're making something, or a combination reaction, right? You're combining together sodium and chlorine, and they're going to bond together and make sodium chloride, table salt, right? That would be one type, the first type of our general type of reactions. The second type would be decomposition. So think about it as destructing, right? You are breaking down one reactant into multiple products, right? So one reactant breaking down into more than one product. So in order to do this, you would need some kind of electricity or thermal energy to be able to break those bonds that are making this material stay solid. Electrolysis is an example of that. You could use electricity to break apart the molecules that are here together as one single reactant and break them into multiple materials at the end of your reaction. So that is the second one. The third kind of reaction are called single replacement reactions. Okay? Single replacement reactions would be kind of like when a substitute comes in, right? One element is in a compound is going to be replaced by another element, right? When a substitute teacher comes in, they're filling the place for another teacher, right? So both an element and a compound are present before and after the reaction. Acids and metals would be examples of these. So when we look at an example of a single replacement reaction, we would be saying we're starting off with a combination of elements, and we are adding a second choice, right, the substitute, and as a result this substitute is going to take the place, right? So maybe now we have A and C and B left, or something along those lines, right? This element's going to come in and take the place of this element so that we have a separate new material formed, and our initial anion is going to be here. The fourth kind of reaction is double replacement. There's a swap going on. I automatically think of like a square dance, right? So you have two compounds that are going to swap cations or anions with each other. There's going to be two reactants and two products, and often a precipitate is going to form, right? So we have our A and B combined together, and now we're going to add our C and D, and as a result they're going to do the switch, right? If this one is positive and this one is negative, this one is positive and this one is negative, We need to write it in a logical way, but we need to show that these two, A and D, right, a positive with a negative, and these two, C and B. Again, we need to write the positive first and the negative, right? So we have a switching of partners, a swapping going on there, and that's a double replacement. Chemical thermodynamics. Energy moves into or out of the reaction process. We can have exothermic, which would be leaving, right? Energy is produced. Combustion. When something is burning, you get heat, right? And thermal energy is produced. In an endothermic reaction, this kind of reaction is going to absorb thermal energy. Instead of heat being given off, heat is a reactant, right? An example of an endothermic reaction would be when you put an ice pack on your twisted ankle. The ice pack is going to absorb thermal energy and cool off your swollen hot ankle and remove some of that heat. Gasoline contains many hydrocarbons, of which octane is the most desirable. So this is just talking about our Dominion science problem relating to the combustibility of that material. So thank you. That's the end of the 19C notes.